Hello. Hello. Some of this program where we wrote a basic program, we use a push button X20 to put on our output Y0, the supply. Okay. Then we use another switch X24 to on our conveyor Y1. Okay, so we convert right to PLC and we started. So anytime we press this, a product is supplied. Okay, but we are facing an issue last week. The issue is whenever a product is supplied, it's not stopping here, okay, and it's falling apart here. So we need a way of making it stop here and then it moves forward. Okay, and for that to happen, that is when we were able to now say, okay, here, this X0 here is your sensor. Okay, this X0 here is your sensor. So we need this sensor to stop product whenever we press this. Just like this, we want our product to stop, but not by stopping the conveyor itself, but a sensor stopping it. So to do that, let's try to put a normally close contact here with the address of the sensor, which is X0. Now, if you check this case, when you press this button X24, okay, when you press it, power is going to flow from here, you know. Let me write to PLC first so you can understand what I mean. Okay, great. Now, if you press this, automatically is normally closed. Okay, a normally closed contact will become normally open whenever it is being energized. Okay, when, for instance, your normally open push button is your start button. When you press it, you engage it. Okay, you engage it when you press it. Let me try to share that with us. I'm coming. Let me see if that is possible. Yeah, yes, a whiteboard. Okay, great. Now, very simple. If I have a button like this button here, sorry for that. This button here is a normally open button. Okay, it's a normally open button. A normally open button. Let me clean that. I'm coming. I should be able to use test for that. A normally open button. Okay, so this normally open button, as it is now, whenever power is coming, yeah, whenever power is coming from this side, okay, and okay, normally open will change state from open back to normally close. So whenever power is being energized, a normally open will become a normally close. Okay, but if at default state, okay, if at default state it is at default state it is a, if it's at default state is a normally close. Okay, let's say if it is a normally close at default state, if it's close, okay, when power is being exercised on it, this normally close contact, when you press it, when you engage it, okay, will become a normally open contact. Okay, so if that is cleared, let me go back to our FX trainer here. What we have here is normally close contact, and we address that normally close to this sensor. So what we are saying now is whenever this sensor senses a product, we expect it to open. And if it opens, that means power will not get to Y1. Now let's do that. Now, currently now, power is getting to Y1. If you check very well here, simulation, front view, you can see that my conveyor is moving here. You can see my conveyor moving very well. Yes, sorry, coming top view. Okay, but you may not know what is going on from this view, front view. Great. Now let me supply product. Product is supplied. Notice something. Immediately the product gets to this sensor, the sensor stop the conveyor because it has now opened this contact. So this conveyor is no longer getting power again. For this conveyor to continue to get power, okay, whether I on and off, nothing change. For it to get power, then that means that I need something to reset this my sensor. I need something to reset that sensor. So let's do something again. Let's press reset. Look at it again. My conveyor is working fine, but immediately I press this, my conveyor is still working. It doesn't stop it. But once it gets to this sensor, my conveyor open this, okay, and so power is not able to get to the conveyor again. So we need something to, to deactivate the sensor or something. So now what we can do now, our main goal is this. Our main goal is whenever, let me change that view to side, sorry. Whenever product is supplied here, this pusher must be able to push to this Y1 conveyor. It should be able to push to this box. Not that my panels, my system will be, just be falling down and all. So to do that, we will say the same sensor that stop the conveyor should start this pusher. This is something that is very normal in these days. I'm telling you. And this is one of the things a lot of people use for, a lot of people use for what they call it, for programming. Very, very important. Okay, so I'm going to do this. We are going to write this program again. The same sensor that stopped the conveyor should on the pusher. So we say X0, which is the sensor. We now put on Y2, okay, which is the pusher. So let's convert, then write it to PLC. Let's convert and write to PLC. Okay, let's see what will happen now. Okay, great. So on our conveyor as usual, we supply a product and watch the drama. Good. Look at that. Now we have somebody coming to pick up the product. Great. Now, but another thing we should look at here is this. Because of this issue, our pusher is not returning back. So even if I supply another product, my conveyor is still on stop mode. So we need to do something again. We need to know why all these issues are happening. So let's put on our conveyor back, press the start and see what is going on. Okay, you stop this, you push this. Okay, now something needs to reset the pusher back because the pusher is still sensing. Now something needs to reset the sensor because now if you check very well, the sensor here It's still sensing this ion. This is a capacitive sensor. It can sense anything here. So it's still sensing this ion. So we need it to reset. We need it to reset whatever is here. Okay. So to do that, I'm coming. So let's reset first. Then we need to know how to bring this guy back. So what we can do is okay, so we say you push, and whenever you are activated, now that's another thing. You can say whenever the sensor is activated, something should happen. It's just like your IFTT. If this, then that. If this, then that. So what we are going to do, if you follow the teacher instruction is something else. For people that asked to follow last week, you notice that's almost the same thing. Okay, this is your X24 on your Y1, which is your conveyor. X20, which is your push button here, on your Y0, which is your supply. X21 on your Y2, which is your pusher. So what they actually do here is they didn't even use the sensor to push. They use a separate thing to push. Okay, so let's flow with that so that I will not go outside this class setup, so that other people that are just joining today will understand. Okay, great. So now let's use another thing for our pusher. Let's use X21 because we actually need a pulse signal for our pushers. Just like you need a pulse signal for your supply command, you need a pulse signal for your pusher, which is here as well. Okay, so X21 will be equal to Y2. Okay, and then how will it stop? Okay, that's another thing to look at. The more you write program, the more you see things not going well, then the more you have to think of how to make things work fine. Okay, so X24, we'll put that on straight away. Then let's start our project again. Okay, now product is sensing it but not stopping. Okay, great. So now let's do something. For our conveyor Y1, let's put X0 here. Normally close up X0. So whenever this sensor senses a product, it will break the continuity between X24 and Y0 and Y1. So that means power will not get to Y1 again. Okay, so let's do that. Let's convert, then write to PLC and see that. Great, good. Now I don't know if you're also following this or you are doing on your own too. You might want to try this. Okay, let's see what's going on here. Correct. The product is meant to stop because this is a normally closed here now. If I use this as normally open, it means until there's product at this particular place before conveyor can move. But because it's a normally closed, conveyor continues to work until this guy senses something and then it breaks the contact. Okay, so now X21 we use as a pusher and then it pushes and our product is done. Very, very simple program. So now conveyor is moving back. You press X20, product is supply. When it gets to the place, pusher came out, and return back. So simple. And then they keep coming to pick the product, and then the supply is made fine. Okay, great. Now that is the first stage of the programming. Exact first stage of the programming. Now we need to understand something. Good. First stage, I have to do some things, 3 things. One, I need to put on start conveyor. Two, start stop supply. Three, press start pusher. You know, why will I need to do all these three things? And I said I'm automating, or I have one automated I have one automated programming. This programming is awesome, but at the same time is causing some nuisance. Okay, because it's not doing what we needed. So we need to find a way of making sure that we increase the level of the productivity. Okay, so let's look at another strategy. Let's think, what if we say, for instance, whenever we press X24, okay, which is our conveyor, and we press X20 to supply product you get here stop automatically on its own, pusher come out, pushes and return back. How do we do this? Let's clear this first program and write. Okay, so we say now X24 will be equal to our conveyor, which is Y0, right? So whenever you press this, power gets to conveyor and conveyor keeps moving. Then we now say again, whenever I press X20, X20 should supply product, okay, supply product, which is equal to Y0. How will our product stop? We said sensor should stop our product. If sensor is to stop our product, we might have an issue, but let's do it. So X20 is equal to sorry, X24 is meant to be equal to Y1. Sorry. So now we convert, we write to PLC. Okay, I press start now. Okay, so for it to stop, that means this X0 has to be in between. So we put X0 here, X0, then we convert, then write to PLC. Okay, so now we press product stop. As product stop, we want that same signal. As the product stop, we want a situation whereby product stopping should be able to on a pusher, and the pusher should be able to return back on the pusher, and the pusher must be able to return back. Okay, so what I'm guessing we can do is, we may say X0, that may not be the way you do your own, but let's just try this, is equal to Y2. Okay, then we can now say that we cannot do what we call interlocking, which means whenever X0 is working, Y2 should not work. I think something will happen there, but let's just try that. So let's put Y2 here. Okay. Okay. And let's see. If you have question along the way, just type it. Just type it as a message to me or drop it on the group. I will reply immediately if the question is related to what we are doing. Okay, let's see now. Wow. Yet we are able to supply, but see, there's continuous signal coming from X0, which is this sensor still sensing, and so it continue to give power to Y2. Okay, it continues to give power to Y2. So what do we do to cancel that? Okay, what if we said okay, this is continually stopping Y0. Oh, this is just pusher. Sorry. This is pusher. Let's cut this. Pusher is not the main deal here. Sorry, it should be for Y1. Where is Y1? Y1, okay, Y1 is convenient for, it should be for Y2 rather. So let's put on Y2. So Y2 stop X0, right? Or what? Yeah, whenever X0 is becoming active. Okay, this is X0. Okay, so Y2. Y2 PLC now. So X24, press. So let's see how this will be now. Okay, now look at the issue now. You were able to bring your product here. So, but because we said, because of the interlock, whenever there is power for X0, we said X1, Y2 must not come up. So we are going to be having this kind of crazy issues here. So what I will suggest, I don't know how you're doing your own, but what I will suggest is this. Now let's do it this way. You can just say, you can simply introduce some nice concept here. For instance, instead of using a push button to continually give my conveyor signal, I can make a push button to work like a switch. Okay, I'm sure everybody should be conversant with what a switch and push button is, but for the sake of people that are not part of this first class, I'll quickly write that. A push button is a spring loaded button. Okay, so you have to press for it to engage. You have to press engage. Okay, but a switch usually retain its original position. That is what happens. A switch will usually retain its original position. If you put a switch at 1, it will remain at 1. If you put a switch at 0, it will remain at 0. If you put a push button, if a push button is a normally closed open, okay, a no NO button, when you press it down, it become a NC. When you release your hand, it go back to NO. Okay, but for a switch, if a switch is at normally open, okay, when you press it down, it become a normally closed. It remain at normally closed, whether you remove your hand or not, it still remain at normally closed. Okay, but for a push button, it is not like that. Very simple, very simple explanation. Okay, so let's go back to what we have here, because along for this project, I want us to be able to learn many concepts. Now, before, we've been using, don't forget, we have been using our switch to put on our conveyor, because our conveyor needs a retain signal. It needs to keep running. Okay, it needs to keep running. So for that to happen, we have to be using a switch, but that is not really advisable in the industry. There are so many things that is attached to it, safety, cost, and all. It is better to use a push button. Okay, so to do that, I'm going to cut all this. This is not for me to prove for you how many program I can do. This class is for you to understand and be able to do something better than what I can do. So I'm going to cut this off. Sorry. Great. And then so I'm going to put, now we want to use a push button. This push button to act like this switch. Very important. Very important. Look at this. So we say x20 will be equal to y1. Now I will convert and write to PLC. I'm not going to rush this class at all for any reason. So if you don't understand anything, just put it as a message. I'm going to reply you. Now look at it. Watch this, your PLC. We are using x20. So x20 will be, this is in x. That's an input. This is 0, 1, 2, 3, 4, 5, 6, 7. Okay, this is 20. So when I press this button, I expect this light here to come up. And then the corresponding output, this is your output side here, okay, which is y, is 1. So I expect this 1 here to come up. So let's press it. Now, can you notice that? See your x20 here coming up as your input. See your y here coming up as an output. Don't forget, I still press it down. Okay, and that is why my conveyor is moving here. You can see this moving. Okay, if I release my hand, the conveyor stop moving. That is how a switch works. Now look at this. The same thing, the same program, the same one-line program I wrote. If I change this address to the address of the switch here, x24, okay, if I just put that and press OK, I have to convert here, then write to PLC. Look at something. Now, if I press this, my conveyor continues to move because this signal is retained to on. Unlike my push button that whenever I press, you see this change to white. When I release my hand, it goes back to its original position. I'm sure that this explanation should be able to make things clearer for us. So now, but now our main goal here is we want this switch to be able to work. I mean, we want this push button. PB means push button, like PB1 here means push button 1. X20 you see here is the address attached to this push button. Okay, now X24 here means switch, SW1 here means switch 1, and this X24 here is the address attached to it. So our goal is we want this switch 1 and this push button 1 to work the same way. Okay, push button 1 should be able to do the same thing switch 1 is doing, and that is what they call latching. Okay, that is what they call latching. I'm going to show us that quickly. Latching. Okay, is just an art of retaining signal. Okay, that is just what it means. Latching just means an art of retaining signal. So if, especially when sending pulse signal, this is very, very important, especially when sending pulse signal. Okay, pulse signal will just come and go. It can be like a clock, okay, like a frequency. It just one come and go. Sometimes the delay might be maybe 5 seconds, 10 seconds, 20 seconds, depending on what you want to achieve. But I'm 100% sure that as long as the pulse signal, it just come and go. And so that is when you have when your circuit or your program is latched. Okay, even when you press that button once, it still retain that signal. Okay, so let me go back here. Good. So now we want this push button to act like this switch. For that to happen, very simple. Put the address of your push button, X20. If you are writing the program, you can write your own like that. Okay. Then at the other end here, then you put this branch, open branch. You click on it and put the address of your output here, which is Y1. You put. Then you convert, then write to PLC. Great. So now let me press my button. Can you see what I'm saying now? Can you see that I don't need to press this down, yet the conveyor is moving? So that is me using my push button to act the same way a switch will act. This is very, very necessary. And if you are with your laptop, you are practicing your own, then you can also do that as well. Okay. Sorry, I have a question from somebody. So if this take us off topic, but I'd like to know how many times you hold meetings, a timetable of sort of. Okay, no problem. You can just check on the group. Okay, just check on the group. No problem. Check the group. Normally we used to have our class every Sunday, but because on last Sunday I was on a trip, so I was late outside, so I couldn't hold it. So I need to hold the meeting today. Okay, so but I'm looking at holding the meeting maybe 2 or 3 times in a week, if possible. I'm very, very extremely busy, so that's one of these when I have to do it in the night. Okay, but I'm still looking at a way of bringing the training more easier for people by making it at least twice in a week. Okay, if that answers your question, fine. If that doesn't answer your question, you can then send me message via WhatsApp. Then via the line I'm gonna drop now, then maybe I can answer your question there. All right. Okay, so let's continue. So now our push button is working just like our switch now. Great. So we've achieved that. The second thing is, now we want this button that is starting this conveyor to supply this product at the same time. See, now we are taking it step by step as a program and this is what program is all about. And then we have to use what they call branch. How do you do that? When you click here, just take your vertical line, press OK, come to the outside of it, and then take your coil for Y0. Don't forget your supply command. This is a robotic arm. Anybody that's worked in the industry before, you know, this always take just a pause signal. It doesn't need a large signal. So even if you use a switch for this guy, it will only work once. It will not work again. For me to prove that for you, let me convert this. I will now quickly write one. Let's put a switch X24 just for you to see. See, just like I've told us before, the goal of this is to understand the concept of programming. So I'm not trying to rush one program for you at all for any reason. So if anybody wants me to rush a program, I can direct you to my YouTube link to go and watch rush programs. Okay, so X24 now. So now we will use it for this Y0. Okay, great. Then we convert. Then write to PLC. I will not start this first program. I will only start this X24. Now look at it. If I press X24, don't forget the signal is on continually now. You expect it to continue to pick product? No, it will not continue to pick product. Even though this shows blue, which means that power is supplied there. It will not, because this needs a pause signal. This power needs to go off and come back on, and go off and come back on. So if I off the switch and put it on back, it will supply another product. That is how it works. But you cannot put it on continually and expect it to give product. It will not give product for you. Okay, great. That is just for you to understand what that place is all about. So let me cut this out, then re-download right to PLC back. Okay, great. So now I press X20. Can you notice that both my robotic arm and my conveyor started together? Okay, both my conveyor and my robotics arm started together. Now, that is the number one thing. Two, we need something to be able to break this relationship, because if something is not breaking it, we will have issues. Okay, so that is why we now introduced a we introduced a what do they call it, we introduced a sensor here in this place. Okay, okay, I still see another message now. Yes, of course it can be done separately. Okay, okay, just let me do that for you. If that is your, if you think that cannot be done separately, it can also be done separately, but I'm trying to make us understand something as well. I'm deleting this, I'm deleting this. Okay, then I'm bringing this back here. Okay, okay, that question is a very good question anyway. It's a very good question. You can use your input as many times as possible. So here I can still say the same x20, okay, to now on my y0. It's still the same thing. This and the first thing I wrote is still the same thing. So let me write to PLC and you see that, because you can use your input as many times as you want. So if I press this, as long as that thing is addressed, I still don't have issues. Anytime I press it, it's still going to work. Okay, it doesn't stop anything, and that doesn't mean my conveyor is stopped. So it's the same thing. I hope that answers that person's question. Okay, great. Now, but we need something to stop this conveyor whenever I get to that place. So personally, what I'm thinking, of course, it has to be the sensor that will stop it. But how will it stop it? How it will stop it matters. Okay, can we just say, for instance, first, can we say x0? X0, which is the sensor, should on our pusher. Let's convert that and see how that will react. Okay, let's see how that will react. Okay, so let's press that and see. It's coming, it's coming. Oh, worked, but it hanged. Worked, but it hanged. Then we need to know why it hanged. Because this x0 is still sensing this. So it hanged and our product remain like that. Okay, can we try to supply another product and see what will happen? So everything will just be fucked up. Okay, great. So that cannot work. So okay, can we now say the sensor should put off the conveyor? Can we say the sensor should put off the conveyor? If we ask the sensor to put off the conveyor, let's see what will happen. Our conveyor is Y1, right? Okay, so conveyor is Y1, so we say control Y1. I mean X0 rather, sorry. Address of the sensor X0. Okay. So we have to cut this out and then write to PLC. Great. We have about 29 minutes more something, so let's see. Now you stop it. Great. You stop, and after you stop, we want pusher to come up. Okay, so for me, I can introduce many things personally. I can say, okay, the same x0 should, I can now maybe introduce timer, for instance. To use timer here is very simple. You can say x0 is equal to, in a PLC, let me quickly share this. In a PLC, you have your timer from 0 to 255. Okay, so you can have from T0 to T255. So that is total of total of 256 timers in a PLC. Okay, very important information. Now let's go back. Great. So now I can even say T0. Then here you have to put space, the number of timing, maybe K10. That's like 10 seconds. Okay. So now anytime this guy dictates a product, it will count for 10 seconds. Then we can say that T0 timer should then on our output, which is Y2. Okay, I have another question again immediately. Sorry. So can you? Yes, this session is recorded. Yes, session is recorded, and then I'm going to post it to the YouTube line. Then you can check it on the YouTube. Okay, great. So now let's try our product again. Let's try it to the PLC and see what's going on. Let's see what's going on. Good. Now let's look at this. When I press X24 now, let's look at what happened. Can you see? Timer began to count, and after counting, my timer put on my Y2. Okay? But the issue is this. My Y2 remained on because nothing is resetting it. So we need something to reset it. So we can say after counting for that timing, I think that time is even too much. Let's say 5 seconds. Okay, after counting for that 5 seconds, don't forget we've introduced many things in this program. We've introduced how to latch in this program. Now we have introduced timer in this same program. The main major things of this program is not to prove whether we can write anything or not. It's for you to understand some concepts. So don't forget those two things. Now we want to reset this timer. We want this timer to be reset. So we can say when this is on, it should on another timer at the same time. Now I'm trying to make this complicated so that you can understand very well. T1 K5 at the same time again. Okay, it should also on T1 K5, and then T1 K5 should now reset the first timer. You can do it in two ways. You can either put a normally close of the timer here, of the T1 here, or you press reset. We will try the second one too, but let's test the first one. Okay, now don't forget, now we have been using one button since morning. Just start button, then again this wait for the time and return. Wow, did you notice that has just worked now? So anytime I press this, get to the place, push, return. That is so nice. But yet we've introduced a timer. We've introduced how a timer can be reset. But yet another thing we should not forget here is that only one product is supplied per time, and after the product is supplied, I will still need to go and be pressing my X20 again. There should be a way, okay? There should be a way by which anytime I press this X20, okay, and supply product, and product is being taken to the right place, and then my the laborers come around to pick the product, and take it to the room, maybe packaging room, whatever the case may be. There should be a way that this product will continue to be supplied itself, automatically. Okay, so we need something that can also help us to trigger these people here. So what can that be? Okay, can we say that the same guy, insert a line, that reset the second timer, the first timer, should also become an or statement here, which is T1. Let's see if that is possible. Write to PLC. Try and follow this very well, because this is just a basic program. The goal of all these classes is to be able to get to the level whereby you'll be able to write any kind of program. Okay, now the product I still need to press, because T1 is not having enough strength to do that job for me. So it's not having enough strength to do that job for me. So side view. Okay, but I need something to become an or statement here, such that either x20 or T1 we put on y0, y1. There must be a way to do that. How do we do that? There must be a way to do that. There must be a way to do that. Okay. And the funny thing is, I know, yes, somebody tell me something now. Okay, now let me show you. What you just told me cannot work, but just for the sake of class, I'm going to show you that straight up. You were thinking maybe it's possible, if it's possible for me to have another y1. You can't have two outputs at a time. That's the issue. You can only have many inputs, but you can't have two outputs at a time. What I'm even thinking right away before you think of that is, why can't we delete this line and probably test it like this and see if that will work. So because now this is having its power here now. This is just programming. You can test and see. It may rearrange it for you. If not rearranging for you, okay, great. So let's see what will happen now. Let's press that. Okay, I'm still able to get power, but yet T1 is not getting enough power to do that job because of how we reset, I'm guessing. So can we do something? Can we say, or let's try this. Can we make T1 even a normally close? Let's try that. No, wait, let's try this for y1, and then let's put T1 here. That's a nice one from you, my guy. Let's see that too. And that's the main goal of this. I can swear that just write a project and put on YouTube, but I want more engaging class like this. Now let's see your suggestion and see how it will work. Now this, if you notice, your suggestion is not, has even spoiled the program the more. That doesn't mean you are a bad programmer, but I'll tell you why. Whenever I press X20 here, okay, nothing is stopping because this guy is outside X20. So it can give power directly to y1 without the influence of this. So because this is inside here, it will not work. Okay, so that will not work. So let's return this back to T1. Okay, and make this back y1. Okay, however, I'm thinking we should flow with the second suggestion. Hey, sorry, what's going on? Something not correct. Cannot be converted. There's a ladder which cannot be converted. Okay, let's see. I think it's this. Okay, great. Now let's see. If you jump from the beginning, this class will be more interesting for you. If you didn't jump from the beginning, you might not understand what you are going through. Okay. Oh, Thank you. I didn't see that as well. Don't forget, we are trying to restart a conveyor. See, this is Y1, which is wrong. We are trying to, instead of Y0. So all this effort here is meant to come to this place, Y0 here. Thank you so much, my guy. Thank you so much. So let's put that here straight up. This should be all statements, okay, of T1. Great. So let's remove T1 here. In fact, T1 is not needed here at all. So delete that line and then remove this as well. Okay, so let's convert and see what will happen now. Right to PLC. Great. So let's press start. See, product supply, put inside. Wow. Wow. Very simple. The program is done. Oh, another issue. Can you notice that is supply back once, but my conveyor is not moving because of what? Why is my conveyor not moving? Let's try to know why. No why. Is it X20? X0? Can it be X0 that is stopping our conveyor from moving? X0. Okay, wait, let's just remove this. This is the only thing we added. Let's see what's going on. Let's know why that is happening. We have just 7 minutes more. Okay, so let's press this. Y0. Okay, Control Z. Y0 X. The same X20 is meant to on Y0. Sorry. Insert a line. X20 is meant to on the same Y0, just like you suggested, and then we convert, then write to PLC. Something very critical we've done today. We've done how to latch. We've used the timer. Okay, and then we are trying to make use of one push button to do all the process we have been using many button for. Okay, now it's working back. Oh, normally before, if you check, normally before here, normally anytime the conveyor has gone back, is not starting back automatically, and that is because of what? This is still kind of engaged. No, that is because we are using a push button. So he still needs somebody to still send signal back to him. Okay, now two things we can do. I think we've achieved this the other time before my other friend told us that we are actually giving power to Y1, not Y0. So the same power we are able to give to Y0, let's try it with this guy too as well. Okay, so we had here, okay, we had here T1. And just like I said before, it will be like this. This. Okay, and then we add this here. Great. So you can remove the other ones because we want it to be outside this place, not to follow the same round. Okay, so we convert. Let's see if this retain our conveyor, then the program is finished. Let's see if it retains our conveyor. Okay, conveyor still move back. Oh, since conveyor can still move back, can you see that conveyor continues to move back? Then let's use the same signal to now supply our command again. Very simple program, very simple. I gave some people this program last week as an assignment, I did not forget that, and I'm going to be asking that anytime from next class. Okay, so write to PLC. So we should have a working program now. Wow. Wow. Can you see that? Very interesting. Just one button. And so that is going to be the end of today's class. Just one button. I expect that to continue to move. Am I correct? Okay. I'm coming. I just noticed something now. It's supplying one, I think, two products. Then stop. Then stop. Let's see why. We have to know why for that too. Although this is meant to be the end of the class, but we need to know why and why that is happening as well. Because that is why you solve problems. And that is why you're a programmer. Okay, so I'm going to cut this off again and see why. As a programmer, you must know why. You can't just assume something is happening or try to just. Most time when you are troubleshooting your program, also people call that debugging, they must know why some certain things are happening. Okay, great. We supply product. Okay, the conveyor is still moving here. Actually, let's wait and see if the conveyor will continue to move like forever. Okay, the conveyor continues to move, so which means nothing is stopping the conveyor actually. Okay, but if I press this again, what happened? Does the conveyor show any sign of stopping? Okay, except when it gets to the place and then it stop. Okay, 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 great. Then when you press for the first time, then it moves, then it continues to move, right? Okay, good. So now, of course, my assignment for the next class is very simple. All I want us to do is this. All I want us to do is that we should be able to write the same program and make just one push button to be able to do all this work. Just the same thing here. Just one push button should be able to do everything that you've seen on this place. You might decide to use my own. You might decide not to use my own, but just to make sure that one push button is doing the work here that we have on this button here. So anytime I just press one button here, then I should be able to get my product supply anytime I press a button in this place. So that'll be the end for today's class. I have over, wow, a lot of people actually joined this class. I didn't know that as well. I'm just saying that now. Okay, great. Thank you all for joining. If you have any question, you can quickly put them out now. If you don't have question or you want to rewatch this session, then you can watch that via the YouTube. Just check the link. The link will be available on the group, just immediately.